Hello everyone. Now we are going to discuss about the geometrical isomerism. Normally, geometrical isomerism is otherwise called as cis-trans isomerism. Why it is called as cis-trans isomerism? So what is geometrical isomers? So the isomers which are having the same molecular formula but differ in the arrangement of atoms around the double bond is known as geometrical isomers. Okay, you can understand this definition. Normally isomers are having the same molecular formula. Here, what is the difference in geometrical isomer? They are also having the same molecular formula. Their difference is arrangement of atoms or groups around the double bond is known as geometrical isomers. This phenomenon is known as geometrical isomerism. The main criteria for the compound exhibiting the geometrical isomerism is the presence of at least one double bond. So we have to know what is the main criteria for the compound exhibiting the geometrical isomerism. It is the main criteria will be the presence of at least one double bond. And different atoms or groups attached to the carbon atom. So to the carbon atom, groups or atoms will be attached to that. So this is the main criteria for a compound exhibiting the geometrical isomerism. Okay. Then the next one is cis and trans-isomers. So already we have discussed about that one, the compound groups or atoms attached to the carbon atoms. Okay, so if same groups or atoms attached to the same side of the double bond, it is known as cis-isomer. If same groups, we can take some example afterwards. In the double bond, if same groups are, for example, hydrogen or methyl, likewise if it is present, same groups are present in the same side of the double bond, it is known as cis-isomer. If the same groups, that is the methyl group or hydrogen atom, if methyl groups are present in the same side, then it is known as cis-isomer. If they are present in the opposite side, they are known as trans-isomers. So in starting I told this geometrical isomerism, otherwise called as cis-trans isomerism. Why it is called as cis-isomer and trans-isomer? Because of this presence of this cis-isomers and trans-isomers. We can take one example. Here we will find that one hydrogen atom is present in the same side of the double bond. Similarly, carboxylic acid is present in the same side of the double bond. This is one example. Malic acid, hydrogen atoms and carboxylic acid, they are present in the same side of the double bond. Hence it is called as cis-isomer. If the atoms, that is hydrogen atom, here you will find that one. This hydrogen is present in one side, one hydrogen is present in the opposite side. Similarly, carboxylic acid group, that is present in one side, one more carboxylic acid is present in the opposite side. So, if same groups are present in the opposite side, then it is called as trans-isomer. The example for this cis-isomer is malic acid, and for trans-isomer will be fumaric acid. So, what are the compounds that will exhibit this geometrical isomerism? That is the compounds containing carbon-carbon double bond, carbon-nitrogen double bond and N double bond N. Like these compounds, they will exhibit the geometrical isomerism. Normally you will know that one, that carbon-carbon double bond contains one pi bond and one sigma bond. This pi bond, one pi bond and one sigma bond will be present in that one. So this pi bond will be formed by overlapping of the p orbitals. So the rotation around the double bond will be restricted. So similarly in geometrical isomers, The atoms which are attached to that carbon-carbon double bonds are groups attached to the carbon-carbon double bond. The rotation will be restricted. Hence, there is no easy rotation. So, if you want to rotate the molecule, you need high energy. So, this is one more example of this cis-isomer. Here we will find that one hydrogen, hydrogen, methane, methane. This one is known as cis-2-butene, and this hydrogen is present in the opposite side. And similarly, methyl group is present in the opposite side. This one is known as cis-2-butene, whereas this one is known as trans-2-butene.